Okay, today we're looking at the sum and differences of areas. So our learning intention is to gain the knowledge in calculating the area bounded by two functions. We'll be successful if we can draw a diagram of the area that we're looking for, create an integral to calculate the required area, add and subtract areas from each other to get the required area. Let's do some examples. Alright, we want to find the area bounded by the line y equals 1 and the curve y equals x squared. Okay, so the first thing I need to do is really find points where they intersect. And during our picture, right, we get -1 and 1. But we can find that by saying if y equals 1 and y equals x squared, sub 1 into 2, yeah, so x equals plus or minus 1. Okay, so we want to find the point of intersections. That's kind of the first step. Okay. I noticed that this is a even function. So what I want to do is I basically want to double this area here, because this area is symmetrical about the y-axis, and we just basically double. So I want to with this one, I want to integrate, let's say from 0 to 1, I'm going to double that, of x squared. Okay. Now, if I was to do that, okay, so I get a third minus 0, so 2/3. What I'm doing when I'm doing this, I'm actually calculating the area here in that really dark pencil line. And by doubling it, I get that. So that's this part. That's not what the question was really asking us to do. The question was really asking us to calculate the middle bit. So thinking of our rectangle, we have a rectangle with a height of 1. Yep. And we've got a length of 2. So the rectangle which is length times width, so it's 2 times 1, which is 2 units. Okay, that's the whole area. Now to get the area between the curve and that line, I'm going to subtract the area of the rectangle with the area under the curve, y equals x squared. So my answer is technically 2 by 1. Yep. Is technically a third. Sorry, 2 minus 2/3 is actually 4 on 3. Okay. Let's look at another example. We want to find the area enclosed between the curve y equals x squared and the line y equals x plus 6. So the first step is to find the point of intersections. Okay, so y equals x squared is 1, y equals x plus 6 is 2, sub 1 into 2 to get x squared equals x plus 6. So x squared minus x minus 6 equals 0. X minus 3, x plus 2. So we get x equals -2 or x equals 3, which correlate to x equals -2 and x equals 3. So what I really want to do is I can calculate, okay, I want to calculate the area under the curve of 3 to -2, yeah, of the function that's on top. And the function that's on top is this y-axis, this y line. Yeah, so that will give me all the area from this line. And then I'm going to subtract the area from the same domain of x squared, which is this area. And what's going to happen is it's going to leave me the area that's bounded by this function. Yeah. So I'm going to calculate the area underneath the line because that's on top. And I'm going to subtract the area under the bottom function to give me the inside function. Okay. So this is going to be x squared over 2 plus 6x between 3 and -2. And I'm going to minus that from x cubed on 3 from 3 to -2. So that's going to give me 9 over 2 plus 18 minus 4 on 2, which is 2, minus 12 minus 27 over 3 is 9 minus -8 on 3. Okay. 9 over 2 plus 18 minus -14, so minus -10. So 25 on 2 minus 9 plus 8 on 3, 35 on 3. And I'm just checking my solutions that I've done previously. So 3 squared over 2, 6 looks of 3 minus 4 over 2 minus 12. So that's 65 on 2 minus 35 on 3. Sorry, gives me 125 on 6, which is approximately 20.83 repeated units squared. Okay, so we're always going to do find the point of intersection, then integral of top minus bottom. Alright, so next example, find the area enclosed by the curves y equals x minus 2, so that's this one here, and the curves y equals x minus 6. So what I really want to do is I want to find this area here. So looking at the first part, I'm going to actually do the integral from 4 to 2, so finding the point of intersection. Yeah. And that can x squared minus 2x plus 4. Okay. And I'm going to add that to the integral from 6 to 4 of x squared minus 12x plus 36. Okay. So if I didn't expand it, you'd still get the same solutions. So we'd get a third x minus 2 to the power 3 from 4 to 2. A third x minus 6 to the power 3 from 6 to 4. Plug in 4 and straighten that from 2, I get 8 thirds. This would be 0 minus 8 thirds, which gives me another 8 thirds, so it gives me 16 over 3 squared units. Okay. Alright, so last example. I want to find the area enclosed between the curve of y equals 4 minus x squared or square root and the line x minus y plus 2 equals 0. Okay, so we know that this is a semicircle. Okay, so we want to basically, we want to find this area here. So using our content knowledge from the Year 12 content for the area, so recognizing that this is a semicircle. Alright, we want to calculate basically the area of this quadrant. So the area of the quadrant so area is a half of the radius is 2 units. So we want a quarter of pi 2 squared. So it's just pi. Okay, so the area of this whole quadrant is pi. Yeah. Now we want to then find the area under this curve. So from -2 to 0 of rearranging this to be y is x plus 2 dx. Okay, so if I integrate that, I get x squared over 2 plus 2x from 0 to -2. So that's going to be 0 minus, so 4 over 2 is 2, minus 4 is -2. Okay, so the area, required area, is pi minus 2 squared units. And that's the answer for that question. All right, good luck.